Today we are working on section 1.4, measuring angles. And let's get a few definitions in here. The first one is an angle is formed by two rays with the same endpoint. And taking a look at this picture down here, we're going to name the angle three different ways. So you can see in this picture, the two rays in my angle are this one, and my other ray is going right here. So that's how an angle is formed, by two rays that have the same endpoint, that endpoint being A. You can name an angle three different ways, but you have to make sure that this vertex, or the one that's kind of in the corner, is always in the middle. So I could name this angle BAC. Notice A is in the middle. I could also name it angle CAB. Again, A is in the middle. Or because there's just one angle here, I could name this angle A. And I could also name it, because of that number there, I also could name it angle 1. So there are really four different ways I could name this angle. In an angle, there are two different parts of the angle. There's an interior and an exterior. That's just where it is. The interior is in this green section right here. It's inside. And the exterior, of course, is everything that is outside of the angle. So let's take a look at our next picture here. It says, what are two other names for angle 1? Here's my angle 1. And I could name this angle, make sure that you have this vertex M in the middle, so I could name it angle JMK, or I could name it angle KMJ. As long as M is in the middle, notice I have both of them right there. Okay, you can also classify angles, and you can classify them four different ways. This should all be review for you. There's an acute angle. An acute angle is between 0 and 90. I believe you need to write the between 0 and 90 right here on your worksheet or your note sheet. A right angle is exactly 90 degrees, and they need to have this little box in the corner in order for you to say that it's a 90-degree angle. If they were to have something drawn like this, and even though it looks like it's 90 degrees, unless they specifically have that box in there, you cannot assume it's a 90-degree angle. An obtuse angle, this value of x has to be less than 180, but it has to be more than 90. So that's how you should write out an obtuse angle. And a straight angle is exactly 180 degrees. So there you can see your four different types of angles. Okay, so let's talk about how you read a protractor. Let's go to page 2 of your notes. And I have here on your note sheet a protractor. And I want to know what are the measures of angle LKN. So here's my first one, LKN. So I can see that LKN is formed by right here. And I know that that is a pretty big angle. It's more than 90 degrees, so it's going to be an obtuse angle, more than 90. So if I were to follow this out, I can see that my line hits that protractor somewhere in there. Now, if my answer has to be more than 90 but less than 180, you certainly aren't going to use this number right here, the smaller numbers, because you need to have a number that's bigger than 90. So that's why you need to go to the larger number here, and you can see you're hit about right there, which is about 145. Okay, the next angle we're going to find is JKL, and JKL is here. So you can take a look at this. This is our angle right here we're trying to find. You know that this entire angle is 90 degrees, so if you were to take away that much of it, which is an acute angle, that angle measures about, I'm at 10, and again, it's acute, it's smaller, so you're not looking at your large numbers, you're looking at your smaller numbers. This angle is about 35. So take your 90, take away 35, and so that angle is about 55 degrees. And you can actually count it out. That'd be 10, 20, 30, 40, 55 is angle JKL. And the last one here is angle JKN. And angle JKN is, let me get this stuff out of here. Angle JKN is going this way, and that is exactly 90 degrees. So that is how you read a protractor. Let's see, angles with the same measure, just like we had in the last section, angles with the same measure are called congruent angles. And you're going to know that they're congruent because they have these little marks, I call them little swoopy marks on your angles. And you can say that angle A is equal to angle B or angle A is congruent. There's that congruent symbol again. Remember, that's an equal sign with this little squiggly over the top. That's congruent. All right, so we have some postulates here. And this one says if point B, here's point B, if it's in the inside of angle AOC, then these two angles, the yellow and the blue, have to equal the entire thing. It's kind of saying like if this is 1 and this is 2, then the whole thing has to be 3. They add up together, called the angle addition postulate. So let's try a few examples here. I'm going to do, this next one says, if angle RQT, and you need to fill in the 155 on your note sheet. If it's 155 degrees, what is the measure of each angle? All right, so this whole angle, this whole entire thing, angle RQT, is 155 degrees. So I know that this part plus this part equals the entire angle. So I'm going to put these together. And I'm going to say 4x and 3x is 7x. Negative 20 and 14 is going to be negative 6. And together it equals 155. Let's see if that pops up. Okay, so now you're going to box road and solve this. This should be pretty simple for you. You're going to add 6 to both sides to get rid of that negative 6. So you're going to have 7x equals 161. And then to solve for x, you're going to divide both sides through by 7. So x is going to be 23. And they want you to solve, let's see, what's the measure of each angle? So each angle is not 23. You should take that value of x and put it back in over here for each angle. So if I'm looking, I'm going to take 23, put it right in here. So 4 times 23 minus 20. Get going on my calculator here. That gives me 72 for that angle. And that looks like about a 72-degree angle. It's an acute angle. Over here, put in 23 for x, so 3 times 23 plus 14. That's going to give me 83. And the nice thing is this. Take the two answers that you just got, your 72 and your 83, put them together and see if you got 155. 72 plus 83, yep, I got it, 155. So you can always check your work to see if you got it right. All right, let's try one more of these. The next one on your sheet says, if angle DEF is a straight angle, what are the measures of angle DEC and CEF? So straight angle, got to think about what a straight angle is. How much is it from here all the way over to here? That's going to be 180 degrees. So you're going to put them together and set them equal to 180. Together, they equal 180. So I have 11x and 2x. I have negative 12 plus 10. Again, you're going to box road here, so get that box around 13x. How do you get rid of that negative 2? Think about that. You're going to add 2 to both sides. So I have 13x equals 182. That 13 is attached to the x by multiplication, so to get rid of that, you're going to divide both sides through by 13. And we get out x is going to be 14. But again, they didn't ask you what x is. They want to know what's the measure of each angle. So take that value of x and put it back into your back up in here. So we're going to have 11 times 14 and then minus 12. This one should be 142. Put your 14 over here. So think about it. That's an acute angle. So you better be getting out an answer that's less than 90. 2 times 14 plus 10. That's going to come out to be 38. Check your work. Ask yourself, 142 and 38, is that coming out to be 180? And it is, so you're good.